Good morning, students. Today we will discuss about the operators available in Python. Wide range of operators are available. You know very well about what the operator is. Operators are the Python construct which performs operations on operands. For example, A is equal to B plus C consists of three operands A, B and C and two operators plus and equal. Operands are those on which operation is to be performed. Here, operation is performed on variables object A, B, and C. Who will perform this operation? Operators will perform such kinds of operations. Plus, the task of plus is to add to object B and C. The task of equal is to assign expression on the right hand side to the variable on the left hand side. So A equal to B plus C consists of three operands A, B and C and two operators equal and plus. Python provides number of categories of operators as Python language giving us list of all these here operators supported by the Pythons: arithmetic operators, assignment operators, comparison or relational operators, logical operators, bitwise operators. Two new operators that are included in all these categories that are membership operators and identity operators. For brief introduction of each operator, you know very well arithmetic operators that perform some arithmetic operations like plus, addition, subtraction, multiplication, division, modulus. Two new operators are added here, that is the floor division and modulus and the exponent operator. In previous programming language there was no exponent operator. If you want to find out 2 raised to 3 we used function, but here exponent function that is provided in Python. Assignment operators equal to is one assignment operators, whatever on the right hand side will be assigned to the variable on the left hand side. Shorthand assignment operators plus equal, minus equal, multiplication equal, division equal, floor division equal and exponent equal. Comparison or relational operators. You know very well, in number of situations we require to compare two variables. So for this we use less than equal, greater than, greater equal and not equal. These are the relational operators. Logical operators, to compare more than one condition. To combine more than two conditions we use logical operators, logical or, either this or this, logical not and logical and. If both true then the result will be true, otherwise result will be false. So these are the logical operators. Bitwise operators that will directly perform the operations on the bit construct of the variable. Number of bitwise operators are available: bitwise AND, bitwise OR, bitwise exclusive OR, bitwise complement, bitwise shift left, bitwise shift right. Membership operators, that is whether a particular member or element is a member or is not member of a given object. Identity operator, that is if both the objects are identical or not, means points to the same memory location or different. It just not compare the value but it performs operation on memory locations, whether both are pointing to the same memory location or not, that we will consider with comparison to equal to operators. So let's start with one by one operators. First that we will start, that is the arithmetic operation. Python provides list of here 7 arithmetic operators: plus, that is simple addition, minus, that is the subtraction, plus multiplication, division, modulus operator, that is the remainder of the division. If I will divide 5 by 2, what the remainder, that will be divided by this modulus operator. Exponents operator, 2 raised to 3 if I want to calculate exponent operator, and floor division. The result that will be the floor division. Floor value, that is, you know, okay, if the value that is given, the floor value of any number 1.2 given, the floor value of 1.2, that is 1. We can say floor value as 1.2 less than value less than or equal to 1.2, but which is the highest one. 1 is the highest one. Number of values are less than 1.2, but it will give you a floor division of a value, that is whatever the answer that comes in real, it will give you the floor division. 1.2 example, then floor value of 1.2, that is 1. Highest integer which is less than or equal to 1.2. 1.2, that is just an example that we have taken. So let's check a program to check all these operators. Here in simple we have given two values to two variables, a equal to 10 and b equal to 20. The simplest program is there. Directly without storing, we are printing the arithmetic operations and that are performed here, and directly we have written into print statement. So a plus b, you know very well, that is addition of this a plus b, that will be 30. 10 plus 20, the result will be here displayed, that is 30. 10 minus 20, if we subtract 20 from 10, the result will be minus 10. A into b, 10 into 20, result will be 200. Multiplying 10 with 20, we will get result, that is 200. Here it is 200. A divided by b, 10 divided by 20. Here it is not like integer division or real. Always the result that will be performed on real, whatever the actual answer that we are getting. So 10 divided by 20, that is 1 by 2. 1 by 2, that is in the form of fractional point, that is 0.5. A modulus 4. If we divide 10 by 4, the remainder will be 10 divided by 4. 4 to the 8. Remainder will be 10 minus 8, that will be 2. So outcome of this remainder operator, that is 2. It will give you the remainder of a division. Floor division, a divided by 3, you know very well, 10. 10 divided by 3, the actual answer, that is 3.3333. But as we have discussed, it will return the floor value. Floor value means the highest integer which is less than equal to 3.333. So here the highest integer which is less than 3.333, that is 3. So answer will be here 3. Outcome will be 3. Then a exponent 2, 10 raised to 2, 10 raised to 2, that is equal to 10 into 10, that is 100. 10 square, that is 100. So output as expected, 30 minus 10, 200. Here modulus, that is 2, 3, that is the floor division, and 100, that is 10 square. Let's check the outcome. As we have expected, 10 plus 20, 10 minus 20, 10 into 20, 10 divided by 20, 10 modulus 4, remainder 2, 10 floor division 3, 3.33, but integer which is highest integer which is less than equal to 3.33, that is 3, and 10 square, that is 100. Next category, that is assignment operators, equal to, widely used to assign whatever on the right hand side, it will evaluate and assign to the left hand side variable. Plus equal, it will add and then assign. For example, instead of writing a equal to a plus b, we can write a plus equal to b. Same way, a minus equal to b, a star equal to b, multiply and assign, a slash equal to b, a star equal to b, modulus, we will require your modulus equal, and floor division slash slash equal and exponent equal. Here there must be a modulus sign, percentage sign. Let's check example here. First, a equal to 10, a plus equal to 5. We have conjuncted these two statements using semicolon. To write two statements in a single line, we use semicolon. A plus equal to 5. First, 5 will be added to this value 10. 10 plus 5, 15, and the value that will be again stored into variable a. So answer will be a, that will be 15. This new updated value 15, we will subtract 10 from this 15. The result of a will be 5. 15 minus 10, that will be 5. Again 5 into 5, 25. That will be again assigned to a. So a will be 25. Now 25 divided by 2, 12.5. That again we will store into a. So a will be containing 12.5. 12.5 modulus equal to 5. Once we will divide 12.5 by integer 5. So 5 to the 10. The remainder will be 2.5 for this division, and again 2.5 that will be assigned to a. So a will be 2.5. 2.5 floor division, that is 2.5 divided by 2, that is 1.25. We want to find out the highest integer which is less than or equal to 1.25, that is 1. So here again this 1 value will be assigned to a, and a will be 1. Next, 1 raised to 2, 1 square, that will be again 1, so outcome will be 1. So let's check the output. First, 15, as we have a plus equal to 5, 10 plus equal to 5, here that is 15. Then 15 minus equal to 10, 15 minus 10, that is 5. Again 5 into 5, that is 25, here 25. 25 divided by 2, here it will be 12.5. 12.5, we are applying modulus, so 5 to the 10, remainder will be 2.5, here 2.5. 2.5 divided by 2, but answer will be 1.25. Floor value will be 1, so output will be 1. And 1 raised to 2, here 1 raised to 2, outcome that will be 1. So now we will compare relational operator, assignment operator, then we will start with relational operator. In many situations we require to compare two objects. Here 6 operators available to compare: equality, equal to, not equal to. If two objects are not equal, then it will give you true, otherwise it will give false. Here greater than or equal to, less than or equal to. So these are the basic operators to compare two objects, and in number of situations we require to use relational operators. Whenever we want to make any branching, in such situation relational operators are used. Let's check the example for this. Here phi equal to phi, both are the same, left hand side as well as right hand side. Phi and phi both are equals, so this equal to equality operator, comparison operator will return true. Phi not equal to phi, we know phi and phi both are equal, so phi not equal to phi, that will return false. Phi greater than 3, it is true, so first that is true, here it is false, again true. Phi greater equal to phi, that is again true, so here true, false, both are true. Now phi less than 3, you know very well that is not true, so phi less than 3 will give you false, and phi less than equal to 3, that will be false. So outcome of this program, that will be true, false, true, true, false, false. Let's check the output. True, false, true, true, false, false. So number of situations we require to use, here instead of constant we can use here variables also, and we must have to use variables in actual program, but to understand these operators we have used here literals and what the outcome of these operators. Now in number of situations we require more than one conditions to check. One condition, okay, we can check using the relational operator, but to check more than one conditions, in such situation we will require to use logical operators. Python provides three logical operators, and that is logical and, or logical or, not logical not. The meaning of this one you are aware. If two expressions connected with and both are true, then the result of this entire expression is true, otherwise result will be false. Or that is either this or this. If two expressions, either of the expression is true, then the result of entire expression connected with or that will be true, otherwise result will be false. We can say for logical and, both of the operands of logical and or both expressions of logical and must be true to get the result true. Or either of true, then result is true. So if both the operands of logical or are false, then only the result of logical or is false. Otherwise, in any case, either both are true, first true and second false, then also true, and first false and second true, then again the result will be true. So here, for short, we can say both true, then true, otherwise false. For or we can say both false, then false, otherwise will be true. Logical not, that is the logical negation of the given expression. The result of the expression must be of true or false. If the result of the expression is true, not will make is not true means false. And if the expression's result of this expression, whatever given, that is false, then not false result will true. Means if it is true, it will give you false. If it is false, it will give you true. So let's check one example for this. Here, two relational expressions, phi equal to phi and 1 greater than 0, both are connected with n. As we have discussed, if both are true, then the result will be true. So here phi equal to phi, that is true. 1 greater 0, that is also true. Both are true. The result of this entire expression will be true and it will print true. Or both false, then only false. So here first phi not equal to phi, that is false. Or 0 greater than 1, that is also false. So both are false, the result will be false. So here it will display false. So first that is true, second will be false. Phi greater than 3, that is true, but not true, that is false. So it will print false. So output will be here true, false and false. Phi greater than 3, true, but not true means false. So outcome will be false. So true, false, true, false. Now bitwise operators. Bitwise operators directly operates on the bit structure of the variable. Directly, whatever the bits are stored, it will perform operations on the bits of the variable. And bitwise and binary and, we call binary and means if both the bits at the same position are 1, then the resultant bit will be 1, otherwise the resultant bit will be 0. Binary or means if both bits at the corresponding positions are 0, then the resultant bit will be 0, otherwise the resultant bit will be 1. Binary exclusive or, if both of the corresponding bits are different, then the resultant bit will be 1, otherwise the resultant bit will be 0. One's complement. One's complement means If bit is 1, it will make at position 0, and corresponding bit if 0, it will make to 1, means complements. For example, if bit structure is 101, this complement operator will make it 010. Shift left, shift the bit to the left hand side as many number of that is given as the argument. If I will use 1, so 1 bit will be shifted to the left. If I will give 2, 2 bits will be shifted. Same way, shift right, it will shift the bits to the right hand side. You know very well. Shift left, that will perform multiplication by 2, and shift right, that will perform division by 2. Let's check the example for this. 10 and 3, you know very well. 1010, that is binary equivalent of 10, and 3, that is 011. In this 2-bit position, you know very well, only the second bit 1, that is common in both these bits position. 1010 from right hand side, second bit that is 1 also here, and also 3, that is 1 available. So resultant answer that will be 0010, that is 2, or 1010 or 011, 3, that is 011. 10 means 1010. So 1010 or 011, that is 1011. 1011, you know, that is equivalent of 11. Exclusive or 1010, exclusive or 011. So different bit in 1010 and 3, that is 1, first one, so it will be 1. Here in 3, first position bit, that is 0, so it will be 1. Then last bit, that is here 0, but here it is 1, so it will be 1, and in between bits will be 0. So 10 exclusive or 3, that will give you 9, 1001. Complement 0, all bits are 0. You know how the numbers are stored in binary, so here it is 0, so all bits are 0. Making all bits to complement means all bits are now 1, so it is the representation of -1, so it will display -1. 5 shift left 2, 2-bit position shifted to the left hand side, so as we have discussed, it will be the multiplication of 2. So one time multiplication, 5 into 2, 10. Second time multiplication, 10 into 2, 20. So here result will be 20. 32 shifted 2 times right hand side. So 32 divided by 2, 16. 16 again divided by second time. So it will be 8. So here it will be result in 20. And here it will be result 8. Let's check the output. As expected, 2, 11, 9, -1, 20 and 8. A better clarification for this bitwise operator, it is suggested, as we have discussed, note down the bit structure of each number, each argument that we have given each number, and then perform. It will be easy to get the answer. Next, membership operators. In evaluate to true if a value lies in the specified sequence and false otherwise. If value lies, then it will true. If not, it will return false. Totally opposite to it, not in. Evaluate to true if value does not lie in the specified sequence, and false otherwise. Let's check the example. Here one example that we have seen. Here list is created 5, 6, 7, 8, 9, 10. Y is created, that is of list of string BCA and CH. Here we have created BBA. So 5 in X, yes, 5 is in X, so it will return true. Same way, 10 in X, yes, 10 is also included in X, so answer will be true. 10 not in X, no, it is false. 10 is there, so 10 not in X, that is false. Same way, 5 not in X, no, 5 is in X, so again it will return false. So 5 not in X, that is false. Why? Because 5 is included in X. Same way, BCA in Y, yes, BCA is there and it is in Y, so result will be true. Z in Y, BBA is not included in this, so result that will be false. So output will be true, true, false, false, true, available, true, available. Here it is false, false, true, false. So true, true, false, false, true, false. Another operators that is available, that is identity operators. Identity operators compare the memory locations of two objects. It is somehow different from the equality operator. Equality operator compares values of two operands. Here it compares memory locations of two objects. Is evaluate to true if both the operands point to the same object and false otherwise, same object in memory otherwise false, and is not evaluates to true if both the operands does not point to the same object, otherwise it will return false. Totally opposite to this, but is an important operator to determine whether both are pointing to same object or not. If they are pointing to the same object, changing in one that may reflect to another also. So let's check the example for this. Here one object that is created list x equal to BCMCA, y is equal to BCMCA. Here x and y totally two distinct objects, two distinct lists with the same content. Here z equal to x, just assignment. Z is also referencing to the same BCA and CA that we have created and stored in x. So print x is z. Yes, it is true. Why? Because both are pointing to the same object. Both are same. We are not talking about the values here, but we are talking z equal to x. X is pointing to the same object list. Z is also pointing to the same object. So both are same. So here it will return true. But x is y? No. Content have same. Z also has the same content BC and CA. Same way, x has also the same content of the, but x is y, that is not true. Why? Because in memory both are distinct or separate objects. The locations of these objects are totally different. So x is y, that is false. Y is z, print y is z. Y is z? No. Again, y is this, it is pointing, y is pointing to this object. Again, z is pointing to this object. Content are similar, but both are pointing to separate objects. So again, y is z will return false. X equal to y. Comparison. Both are equal? Yes, both are equal. Both are have the same elements, same number of elements, and same content are there. BCA, BCA, MCA, MCA. So both are same. So it is true. Same way, if you will compare z equal to y, here z again pointing to the referencing to the same object that is pointing by the reference x. So BCMC, z containing BCMC, same way y containing this second list BCMC. So if we will compare the content point of view, both are same. So only the difference that you have to remember here, equality operator just compares the value that is stored in object. Here member by member it will compare, and if both are same then it will return true. So it just checks the value. Y is operator that compares the memory location. Same way, if in first example we have seen that is true, x is z, yes, both are referring to the same object. So if you will write x is not z, if we will write x is not z here, is not, so it will return false. If we will write x is not z, it will return false. So outcome as expected here, true, false, false, true. Here true, true, false, x is z true, x is y false, false. Both are comparing, that is true. So we have discussed about the operators available in this Python operators. It is suggested you can experiment more and write other programs to see the effectiveness of the Python operators. Have a good day. Thank you very much.